November 1st, 1943. The northern sector of Bougainville Island, Solomon Islands. Private First Class Andrew Hogan crouched in the volcanic mud, 72 pounds of steel tanks strapped to his back, watching a Japanese pillbox that had already killed 6 Marines that morning. The concrete structure sat partially buried in the hillside, its firing aperture a black slot spitting machine gun fire across 50 yards of exposed ground. Artillery had failed to crack it. Rifle grenades had bounced harmlessly off its reinforced walls. Now, as morning mist clung to the jungle canopy, Hogan checked the valve on his M2-2 flamethrower and prepared to become what Marines would later call the most dangerous man on the battlefield. What the Japanese defenders inside that bunker didn't know was that the weapon Hogan carried represented a quantum leap in American flame warfare technology. The earlier M1 flamethrower, with its 25-yard maximum range, had forced operators to advance within rifle range of enemy positions, resulting in catastrophic casualties. The M2-2, introduced just 8 months earlier in March of 1943, could project burning napalm 40 yards, doubling the survivable distance while delivering temperatures exceeding 1,500 degrees Fahrenheit. The mathematics of death were about to change on Bougainville. In the next 4 hours, Hogan and 3 other flamethrower operators would neutralize 17 Japanese positions that had resisted days of conventional assault. Their success would come at a terrible price. By sunset, 2 of the 4 flame operators would be dead. 1 would be critically wounded, and Hogan himself would carry psychological scars that no amount of medals could heal. The age of the portable flamethrower had arrived in the Pacific War, and it would transform the nature of combat in ways that strategists had never anticipated, and soldiers on both sides would never forget. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Imperial Japanese Army's defensive doctrine in 1943 centered on a fundamental assumption. American infantry could not sustain the casualties necessary to assault fortified positions at close range. This calculation wasn't mere bravado but a mathematical assessment based on early Pacific battles. At Tarawa in November of 1943, Japanese defenders had inflicted 7,300 casualties while losing their entire garrison of 4,800 men. The exchange rate favored defense, and Japanese planners believed that sufficient fortifications could make American victory prohibitively expensive. The keystone of this defensive strategy was the reinforced concrete pillbox, a military engineering achievement that represented years of refinement. Standard Japanese Type 97 pillboxes featured walls 4 feet thick, constructed from concrete reinforced with steel rods and coconut logs. The firing apertures measured just 18 inches wide by 6 inches high, providing minimal exposure while allowing interlocking fields of fire with adjacent positions. Ventilation shafts, camouflaged and positioned away from direct line of fire, provided fresh air while dispersing the smoke and heat from sustained firing. These fortifications had proven nearly impregnable to conventional weapons. Naval bombardment, even from 16-inch naval rifles, could strike direct hits without penetrating properly constructed pillboxes. The shells would crater the ground around the position, strip away camouflage, even bury some structures under tons of displaced earth. But the defenders inside often emerged unscathed once the barrage lifted. Artillery fire proved similarly ineffective. High explosive shells lacked the precision to strike the small firing apertures, and even direct hits on the concrete structure rarely achieved more than superficial damage. American infantry tactics in early Pacific campaigns had relied on suppressive fire from rifles and machine guns while engineers attempted to approach with demolition charges. This method worked, but at horrific cost. Engineers advancing across open ground toward pillboxes suffered casualty rates exceeding 70% in some operations. The Japanese defenders, protected behind reinforced concrete, could maintain accurate fire until the last possible moment. Even when engineers reached a pillbox and successfully placed explosives, the interconnected nature of Japanese defensive positions meant adjacent bunkers could fire on the demolition team during their approach or retreat. The tactical stalemate favored defense so heavily that American planners began seeking alternative weapon systems. Chemical warfare offered one possibility, but the United States had renounced first use of poison gas. Flame weapons, however, occupied a different category. Incendiary devices had been used since ancient times, and their employment against fortified positions didn't violate any international conventions to which the United States was a party. More importantly, flame weapons offered a unique capability. They could kill through heat and oxygen depletion without requiring direct line of sight to the target. The United States Army Chemical Warfare Service had been experimenting with portable flamethrowers since 1941. The initial M1 model, a hasty adaptation of British designs, entered service in late 1942. The weapon consisted of two cylindrical fuel tanks, one containing gasoline and the other a thickening agent, connected to a nitrogen pressure tank and a flame gun with an electrical ignition system. Total weight fully loaded reached 68 pounds. An enormous burden for infantry already carrying rifle ammunition, grenades, and other equipment. The M1's performance in early Pacific combat revealed critical limitations that nearly doomed the entire flamethrower program. Maximum effective range measured just 20 to 25 yards, forcing operators to advance within close rifle range of enemy positions. The weapon's signature was unmistakable. The black smoke from burning petroleum made operators instantly identifiable to enemy gunners. Worst of all, the fuel capacity allowed only 8 to 10 seconds of continuous fire, meaning operators had a single chance to neutralize their target before becoming defenseless. Casualty statistics from Guadalcanal told a grim story. Flamethrower operators suffered losses exceeding 70% in some operations, with individual companies reporting 92% casualties among flame personnel. These horrific numbers threatened to make the weapon operationally unusable. No amount of tactical value could justify losses that would exhaust available operators in a single engagement. The Chemical Warfare Service faced a stark choice: dramatically improve flamethrower performance or abandon the weapon system entirely. The breakthrough came through systematic analysis of combat failures. Engineers studied after-action reports, interviewed surviving operators, and conducted extensive testing at the Edgewood Arsenal in Maryland. They identified 3 critical problems requiring solution: insufficient range exposed operators to unnecessary danger, inadequate fuel capacity limited engagement time, and unreliable ignition systems caused frequent malfunctions under combat conditions. The solution emerged as the M2-2 flamethrower, a complete redesign rather than an incremental improvement. The weapon retained the basic configuration of back-mounted fuel tanks and handheld flame gun, but nearly every component underwent engineering refinement. The most significant change involved the fuel system. The M2-2 employed 2 4-gallon fuel tanks containing a carefully calibrated mixture of gasoline and napalm thickener, developed by chemists at Harvard University specifically for flame warfare applications. Napalm, a portmanteau of naphthenic and palmitic acids used in its formulation, transformed flamethrower effectiveness. The thickening agent turned liquid gasoline into a viscous gel that clung to surfaces rather than splashing off harmlessly. This adhesive quality meant that napalm could stick to concrete bunker walls, flow through firing apertures, and coat everything inside a defensive position with burning petroleum jelly. The fuel mixture burned at temperatures between 1200 and 1500 degrees Fahrenheit, hot enough to melt steel and instantly fatal to anyone within the flame radius. The pressure system also received complete redesign. A single nitrogen pressure tank, charged to 350 pounds per square inch, provided the force to project fuel through the flame gun. Nitrogen was chosen over compressed air specifically because it wouldn't support combustion if the tank was punctured. This safety feature proved critical, as the tanks made conspicuous targets for enemy gunners. A hit to the pressure tank would vent nitrogen harmlessly rather than igniting the fuel, giving the operator a chance to survive and withdraw. The flame gun itself incorporated lessons from hundreds of hours of combat testing. The ignition system used a battery-powered electrical arc rather than a pilot light, providing reliable ignition in the humid tropical conditions where pilot lights frequently failed. The nozzle design created a concentrated stream rather than a dispersed spray, extending maximum range to 40 yards while maintaining the ability to sweep across a wide area with short bursts. Total weight of the M2-2 reached 72 pounds when fully loaded, slightly heavier than the M1 but with dramatically improved performance. Fuel capacity had doubled, allowing up to 10 seconds of continuous fire or 20 to 25 short bursts of 1 to 2 seconds each. This extended engagement time meant operators could neutralize multiple positions or maintain suppressive fire while maneuvering. The weapon's distinctive appearance, two cylindrical tanks on an H-frame harness with canvas straps, would become one of the Pacific War's most recognizable images. Production began in March of 1943 at multiple facilities across the United States. The M22's relatively simple construction, compared to firearms requiring precision machining, allowed rapid manufacturing scale-up. By June of 1943, production reached 500 units per month. By December, output had increased to 1,500 units monthly, with priority allocation going to Marine Corps units preparing for Central Pacific operations. Training for flamethrower operators became increasingly sophisticated as tactical doctrine evolved. The Marine Corps established specialized schools at Camp Pendleton, California, and Camp Lejeune, North Carolina, where volunteers learned not just weapon operation but the complex tactics necessary for survival. Instructors emphasized that flamethrowers were not assault weapons but specialized tools for reducing fortified positions, requiring careful integration with rifle squads and demolition teams. The selection process for flamethrower operators revealed the weapon's psychological demands. Marines had to volunteer, as commanders recognized that forcing unwilling men to carry such conspicuous and dangerous weapons would be counterproductive. Volunteers tended to be younger Marines, often 18 to 20 years old, who saw the flamethrower as a path to distinction and rapid promotion. What they didn't always understand until combat was the terrible isolation of being marked for death the moment they revealed their weapon. The tactical doctrine that emerged from training emphasized several key principles. First, flamethrower operators never advanced alone. Each flame team consisted of the operator plus 4 riflemen who provided covering fire and protection. Second, the element of surprise was crucial. Operators concealed their weapons under ponchos or remained hidden until the critical moment of engagement. Third, the first burst had to count. With limited fuel and a signature that drew instant enemy attention, operators couldn't afford reconnaissance by fire or ranging shots. Japanese forces, meanwhile, were developing their own counter-tactics. Intelligence reports from Guadalcanal and New Guinea emphasized the vulnerability of flamethrower operators to concentrated rifle fire. Training manuals issued to infantry units in mid-1943 specifically addressed anti-flamethrower tactics. Machine gunners received instructions to identify and prioritize flame operators, recognizable by their bulky backpack tanks and distinctive weapon profile. Snipers were allocated extra ammunition specifically for targeting operators before they could reach effective range. Japanese defensive positions incorporated design features intended to counter flame weapons. Firing apertures included steel shutters that could be closed between bursts, preventing flame from entering the pillbox. Multiple exit points allowed defenders to escape if their position was compromised. Some bunkers included internal water supplies for fighting fires, though this measure proved largely ineffective against napalm's intense heat. The most effective countermeasure was simply maintaining distance, forcing operators to cross as much open ground as possible before reaching effective range. The first large-scale employment of M2-2 flamethrowers came during the November 1943 invasion of Bougainville. The 1st Marine Division landed with 48 flamethrowers distributed among infantry battalions, each weapon assigned to specially trained operators who had practiced assault tactics for months. The Japanese 6th Division, defending the island with approximately 35,000 troops, had constructed an elaborate network of bunkers and pillboxes according to the latest defensive doctrine. Private Andrew Hogan, mentioned in the opening, was among the first operators to test the M2-2 in sustained combat. His company, Fox Company, 2nd Battalion, 3rd Marines, had been stalled for 2 days attempting to reduce a Japanese strongpoint designated Hill 69. The position consisted of 7 interconnected pillboxes arranged in a semicircle, providing interlocking fields of fire that made frontal assault suicidal. Artillery had been pounding the position for 36 hours with minimal effect. At 07:30 on November 1st, Hogan and his 4-man protection team began their approach. The tactic was methodical, developed through training and refined by bitter experience on Guadalcanal. The protection team advanced first, using covering fire from adjacent positions to suppress Japanese return fire. Hogan followed 20 yards behind, moving quickly between covered positions, the 72-pound weapon making him slow and vulnerable during exposed movement. At 45 yards from the nearest pillbox, Hogan halted behind a fallen tree, checking his weapon one final time. The electrical ignition system required a manual trigger, and operators learned to test it before committing to the final assault. A small spark confirmed the system was functional. The pressure gauge read 330 pounds per square inch, optimal for maximum range. Fuel tanks showed full. Every mechanical component indicated readiness, but no amount of preparation could eliminate the terror of what came next. The final approach required crossing 15 yards of open ground, a distance that took perhaps 8 seconds but felt like eternity under fire. Hogan's protection team laid down suppressive fire, rifles and Browning automatic rifles hammering at the pillbox's firing aperture. The Japanese machine gun, momentarily silenced by the volume of incoming rounds, gave Hogan his window. He sprinted forward, 72 pounds of flamethrower equipment making each step an effort, reaching a shell crater 35 yards from the pillbox. From this position, Hogan had clear line of sight to the bunker's firing aperture. He raised the flame gun, an awkward process with the weapon's weight and bulk, and triggered the ignition. The electrical arc snapped, and a stream of burning napalm erupted from the nozzle, arcing through the tropical air like liquid fire. The burning gel struck the concrete wall around the firing aperture, splashing into the opening and flowing inside like molten lava. The effect was instantaneous and horrifying. Temperatures inside the pillbox soared past 1200 degrees in seconds. The oxygen was consumed so rapidly that defenders suffocated before the flames reached them. Those who didn't die from oxygen depletion were incinerated by napalm that clung to skin, uniforms, equipment, everything it touched. Smoke billowed from the ventilation shafts as secondary fires ignited stored ammunition and supplies. Within 20 seconds, the position that had resisted 2 days of conventional assault was neutralized. But Hogan's work wasn't finished. The interconnected defensive system meant adjacent pillboxes could still fire on his position. As he traversed toward the second bunker, a Japanese sniper, positioned specifically to target flamethrower operators, opened fire. The first round struck Hogan's left fuel tank, penetrating the metal with a sharp clang. Nitrogen gas vented with a hissing sound, reducing pressure but not igniting the fuel. The nitrogen safety system had worked exactly as designed, preventing the catastrophic explosion that would have killed Hogan instantly. With pressure dropping rapidly, Hogan had perhaps 10 seconds of effective flame remaining. He pivoted toward the second pillbox, now just 30 yards away, and triggered another burst. The reduced pressure shortened his range, but the napalm still reached the target, splashing across the bunker's exterior and flowing through gaps in the camouflage. Fire spread across the position's roof and walls, forcing defenders to choose between burning inside or fleeing into Marine rifle fire. 3 Japanese soldiers emerged from a rear exit, hands raised in surrender, preferring capture to incineration. Hogan withdrew under covering fire from his protection team, the damaged flamethrower making him even more vulnerable during the retreat. Behind him, both pillboxes burned, black smoke rising above the jungle canopy. In less than 3 minutes of engagement, he had accomplished what 2 days of artillery and rifle fire could not. But the victory came with stark awareness of his own mortality. The sniper's bullet that struck his fuel tank had missed his spine by inches. Next time, he might not be so fortunate. The statistics from Bougainville's first week validated the M22's tactical revolution while confirming the terrible cost. Flamethrower-equipped units reported 47 fortified positions neutralized in situations where conventional assault would have been prohibitively expensive. Marine casualties in flame-supported attacks dropped by 35% compared to unsupported assaults. The weapons had proven their value beyond question. But flamethrower operator casualties remained at 68%, barely improved from the M1's dismal record. The extended range helped, but not enough to fundamentally change the operator's survival odds. The psychological burden on flamethrower operators extended beyond physical danger. Marines who survived their first engagement often struggled with what they had inflicted. Corporal James Hansen, who operated an M2-2 at Tarawa in November of 1943, later testified in a post-war interview, "You could hear them screaming when the napalm hit. It didn't last long, maybe 5 or 10 seconds, but you heard it. I still hear it sometimes. We did what we had to do, but some things you can't forget. The smell especially. Burning fuel mixed with everything else. That smell got into your equipment, your uniform. It never really went away." The Japanese response to the M22's introduction evolved rapidly through intelligence gathered from captured equipment and battlefield observations. By December of 1943, Japanese training manuals had been updated with specific anti-flamethrower tactics. Infantry units practiced identifying operators by their distinctive silhouette, the twin cylindrical tanks creating a profile unlike any other infantryman. Machine gun crews received explicit orders to concentrate fire on anyone carrying flamethrowers, with some units offering special recognition to soldiers who successfully killed flame operators. More significantly, Japanese engineers began modifying defensive positions to counter the extended range that made the M2-2 so effective. Pillboxes constructed after late 1943 often featured offset firing apertures, angled passages that prevented direct line of sight from outside to inside the bunker. This design meant napalm couldn't flow directly through the firing port, but had to navigate corners and turns, significantly reducing flame penetration. Some positions incorporated multiple chambers, allowing defenders to retreat from a compromised front section while maintaining firing positions from deeper chambers. The most effective Japanese counter-tactic proved to be the simplest, extending the defensive perimeter. By forcing Marines to cross 60 or 70 yards of open ground rather than 40, Japanese defenders could engage flamethrower operators before they reached effective range. This tactic required sacrificing some fields of fire and creating gaps in defensive coverage. But Japanese commanders calculated that eliminating flame operators before they could employ their weapons justified the trade-off. The November 1943 assault on Tarawa Atoll provided the most comprehensive test of M2-2 capabilities under the worst possible conditions. The 2nd Marine Division landed with 32 flamethrowers distributed among assault battalions. The Japanese garrison, approximately 4,800 naval infantry under Rear Admiral Keiji Shibasaki, had transformed the tiny island into a fortress that Japanese propaganda claimed couldn't be taken by 1,000,000 men in 100 years. The reality confronting Marine flamethrower operators at Tarawa exceeded anything encountered in training or previous combat. Japanese positions weren't simply reinforced concrete pillboxes but elaborate bunker complexes with multiple firing positions, interconnected tunnels, and layered defenses. Some bunkers featured walls 5 feet thick constructed from concrete reinforced with steel rails from a demolished railway. Naval bombardment that should have pulverized these structures left them largely intact, scarred but functional. Private First Class Robert Raysbrook, carrying an M2-2 with Company E, 2nd Battalion, 8th Marines, landed in the 5th wave on Bougainville Island's Red Beach 2. What followed illustrated both the flamethrower's capabilities and its terrible limitations. Raysbrook's boat grounded on the reef 800 yards from shore, forcing Marines to wade through chest-deep water while Japanese machine guns swept the approach. Of the 32 flamethrower operators who landed at Tarawa, 11 drowned before reaching shore, pulled under by the 72-pound weight of their equipment when they stepped into unexpected depressions in the reef. Raysbrook reached the beach after 40 minutes of waiting under fire, exhausted and soaked. The M22's designers had waterproofed critical components, but salt water penetration remained a constant concern. He found cover behind a disabled Amtrak, one of dozens of destroyed amphibious vehicles littering the beach, and checked his weapon. The electrical ignition system sparked correctly. Pressure gauge showed 290 pounds, reduced from the standard 350, likely from a minor leak during the landing. Still sufficient for operation. The Japanese bunker that had destroyed Raysbrook's Amtrak sat 75 yards inland, its firing aperture a dark slot spitting machine gun fire that kept Marines pinned on the beach. 2 previous attempts to assault the position had failed with total casualties. The bunker's construction exceeded standard Type 97 specifications, with visible reinforcement and what appeared to be multiple firing positions at different angles. Raysbrook's assault team consisted of himself and 3 riflemen, 1 man short of the standard 5-man flame team because his 4th rifleman had been killed during the landing. The approach required crossing 50 yards of exposed sand, an impossible distance under the Japanese machine guns' sustained fire. The solution came from an adjacent tank, an M3 Stuart light tank that had managed to reach the beach intact. The tank commander agreed to provide covering fire and physical cover, allowing Raisbrook to advance behind the vehicle. The Stuart moved forward at walking pace, Raisbrook crouching behind its rear hull while the tank's 37mm gun and machine guns hammered the Japanese position. At 45 yards, close enough for effective flamethrower range but exposed if the tank was disabled, Raisbrook prepared to engage. The Japanese defenders, recognizing the threat, concentrated fire on the tank. A 47mm anti-tank gun, previously hidden, fired point-blank at the Stuart. The shell penetrated the light tank's thin armor, killing the driver instantly. The tank lurched to a halt, smoke pouring from the engine compartment. Raisbrook found himself exposed, 45 yards from the bunker with no cover except the burning tank. In the seconds before Japanese gunners adjusted their aim from the tank to him, he raised the flame gun and triggered the ignition. A stream of burning napalm arced through the air, crossing the distance in less than 2 seconds, striking the bunker's firing aperture with devastating accuracy. But this bunker's design included the offset firing port that Japanese engineers had recently developed. The napalm splashed into the aperture but couldn't flow directly into the bunker's interior. Raisbrook could see flames burning at the entrance, but the defenders remained protected in their deeper chambers. He triggered another burst, maintaining fire for 4 seconds, depleting precious fuel but determined to neutralize the position. The sustained flame created enough heat to ignite wooden supports inside the bunker, and smoke began billowing from multiple openings. Japanese soldiers emerged from a rear exit, attempting to escape the smoke-filled bunker. Marine riflemen cut them down before they could reach cover. But the position still wasn't fully neutralized. Raisbrook's protection team rushed forward with demolition charges, placing 40 pounds of explosives at the bunker's entrance, while Raisbrook provided covering flame. The explosion collapsed the entrance and sealed the position permanently, along with any defenders still inside. Raisbrook had expended 7 of his weapon's 10 seconds of fuel capacity to neutralize a single bunker. The M22's doubled fuel load compared to the M1 had given him options the earlier weapon couldn't provide: the ability to sustain fire, adjust aim, and maintain pressure on the target. But even with improved capacity, flamethrower operators at Tarawa found themselves running dry with multiple targets still requiring reduction. The statistics from Tarawa's 76 hours of combat told a grim story. Of 32 flamethrower operators who landed, 23 became casualties, a 72% loss rate that exceeded even the horrific overall Marine casualty figure of 53%. The 11 operators who survived had neutralized 41 Japanese positions, an average of nearly 4 bunkers per surviving operator. These numbers validated the weapon's tactical effectiveness, while confirming that operating an M2-2 remained one of the most dangerous assignments in the Pacific War. Post-battle analysis revealed patterns that would influence future operations. Flamethrower operators who survived tended to be those who advanced with tank support, used terrain features for cover during approach, and worked with full 5-man protection teams. Operators who attempted solo advances or couldn't coordinate with supporting arms suffered the highest casualties. The weapons themselves proved remarkably reliable despite the harsh conditions. Only 2 M2-2s experienced mechanical failures during the battle, both due to saltwater damage to the electrical ignition system, a failure rate under 7% that impressed chemical warfare service engineers. The Japanese defenders at Tarawa had inflicted terrible casualties on flamethrower operators, but they had also learned a sobering lesson. The M22's 40-yard range meant their carefully constructed bunkers, designed to withstand naval bombardment and artillery fire, could be neutralized by a single Marine with a specialized weapon. Admiral Shibasaki's boast that Tarawa couldn't be taken by 1,000,000 men in 100 years had been proven false in 76 hours. Flamethrowers hadn't won the battle alone, but they had broken defensive positions that conventional weapons couldn't reduce at acceptable cost. By early 1944, the M2-2 flamethrower had become standard equipment in Marine Corps infantry battalions. The table of organization authorized 24 flamethrowers per division, distributed to provide specialized capability without creating dependency on a weapon that required unique logistics and training. The Chemical Warfare Service established a production target of 5,000 M2-2 units for 1944, with priority allocation to Pacific Theater operations. Training evolved to address lessons learned at Tarawa and Bougainville. The Marine Corps established dedicated flamethrower schools where operators spent 2 weeks learning not just weapon operation but integrated tactics with demolition teams, tank units, and rifle squads. Instructors emphasized survival techniques, using terrain, coordinating with support weapons, and the critical importance of the protection team. Survival rates among operators with formal training exceeded those of Marines who learned on the job by 25%, a statistically significant difference that justified the training investment. The physiological demands of operating an M2-2 received increasing attention as more data accumulated. Carrying 72 pounds of equipment in tropical heat while conducting assault operations required exceptional physical conditioning. The weapon's weight distribution, with most mass concentrated on the back, created balance and mobility problems. Marines learned to lean forward slightly while moving, compensating for the rearward weight, but this posture made rapid movement nearly impossible. The June 1944 invasion of Saipan saw the M22's employment reach new levels of tactical sophistication. The 2nd and 4th Marine Divisions landed with 48 flamethrowers each, and commanders had developed specific assault doctrines for their employment. Japanese defenders, the 31st Army under Lieutenant General Yoshitsugu Saito, had constructed defensive positions incorporating lessons from Tarawa, including offset firing ports and extended defensive perimeters designed specifically to counter flame weapons. Corporal Donald Graves, a flamethrower operator with Company F, 23rd Marines, participated in what would become the textbook example of integrated flamethrower tactics. His target was a Japanese strongpoint designated Purple Heart Ridge, a coral outcropping honeycombed with interconnected caves and bunkers. Previous assaults had failed with casualties exceeding 100% in some platoons, as replacements for wounded Marines were themselves hit before reaching their units. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The assault plan for Purple Heart Ridge represented a revolution in combined arms tactics. Artillery would suppress known Japanese positions while tanks advanced to provide mobile cover. Engineer teams with demolition charges would follow the tanks, and flamethrower operators would neutralize positions that conventional weapons couldn't reduce. The entire operation would be coordinated by radio, a level of tactical integration that required extensive rehearsal. At 0800 on June 20, 1944, the assault began. Graves advanced behind an M4 Sherman tank, accompanied by his 5-man protection team and a 4-man engineered demolition squad. The coordination was precise. The tank would advance to within 30 yards of a bunker, engaging with its 75mm gun and machine guns to suppress defensive fire. Graves would then move to the tank side, using its bulk for cover while engaging the bunker with his M2-2. Finally, engineers would rush forward to place demolition charges, while Graves provided covering flame. The first bunker fell to this coordinated assault within minutes. Graves' 40-yard flame range allowed him to engage while still protected by the tank's armor. The napalm flowed into the bunker's offset firing port, and while it couldn't penetrate directly into the interior, the sustained flame created enough heat and smoke to force defenders out or incapacitate them. Engineers placed demolition charges while Japanese soldiers were still reeling from the flame attack, sealing the position permanently. The second bunker revealed a new Japanese counter-tactic. As Graves prepared to engage, a Japanese soldier emerged from a concealed spider hole just 15 yards away, carrying a satchel charge intended to destroy the supporting tank. Graves' protection team, specifically positioned to counter such threats, opened fire immediately. The Japanese soldier died 10 feet from the tank, his explosive charge detonating harmlessly in the coral. This incident validated the doctrine that flamethrower operators required dedicated protection teams, as the operator's focus on his primary target made him vulnerable to close-range threats. Over 6 hours of sustained combat, Graves' integrated team neutralized 9 Japanese positions on Purple Heart Ridge. His M2-2 required refueling twice, a process that took 15 minutes each time and required withdrawing to a supply point 800 yards to the rear. The refueling stations, established specifically to support flamethrower operations, became critical nodes in the logistics network. Each station maintained stocks of premixed napalm fuel, replacement nitrogen pressure cylinders, and spare parts for field repairs. The Saipan campaign demonstrated that when properly integrated with tanks, engineers, and supporting infantry, flamethrowers could reduce fortified positions with acceptable casualties. Graves survived the battle, one of 39 flamethrower operators from the 4th Marine Division who lived through Saipan's 25 days of combat. 9 operators were killed, a casualty rate of 18% that represented dramatic improvement over Tarawa's 72%. The difference lay entirely in tactics, training, and integration with supporting arms. Japanese military intelligence analyzed American flamethrower tactics with increasing concern. Captured documents from Saipan revealed detailed assessments of the M22's capabilities and recommended countermeasures. One report noted, "The enemy flame weapon has effective range exceeding 40 meters, making approach to fortified positions extremely dangerous. Operators are heavily burdened and move slowly, but they advance with tank support that makes targeting them difficult. Snipers achieve best results when they can engage operators before tank cover is available." The September 1944 invasion of Peleliu would test both American flamethrower tactics and Japanese countermeasures in the war's most challenging cave warfare environment. The 1st Marine Division landed with 24 M2-2 flamethrowers, facing a Japanese garrison of approximately 11,000 troops under Colonel Kunio Nakagawa. The Coral Islands' geography featured hundreds of natural caves and ravines that Japanese engineers had transformed into a defensive system of unprecedented complexity. Private Eugene Sledge, who would later write one of the Pacific War's most acclaimed memoirs, witnessed flamethrower operations at Peleliu, though he wasn't an operator himself. His observations provide valuable perspective on how Rifle Company Marines viewed the weapon and its operators. Sledge noted that flamethrower men were both respected for their courage and pitted for the terrible burden they carried. "The flamethrower was a cruel weapon," he wrote. "I hated to see it used, but it was absolutely necessary to get the Japanese out of their caves and bunkers. Nothing else worked." The caves at Peleliu presented unique challenges that tested M2-2 capabilities to their limits. Many cave entrances opened onto sheer cliff faces or were positioned in defilade where operators couldn't achieve direct line of sight. The interconnected nature of the cave systems meant that burning out one entrance might simply drive defenders deeper into the complex, where they could reemerge from another opening. Some caves featured multiple levels and galleries extending hundreds of feet into the coral ridge, far beyond any flame weapon's range. Corporal Andrew Hogan, now a veteran of Bougainville and Saipan, participated in the reduction of what Marines called the horseshoe, a curving coral ridge containing over 30 interconnected cave positions. The tactical problem seemed insurmountable. Cave entrances dotted the cliff face at varying elevations, many accessible only by climbing exposed rock while under fire from multiple positions. Conventional tactics called for sealing caves with demolitions, but at the horseshoe, destroying one cave often triggered collapse of adjacent positions, creating a tactical whack-a-mole where each solution created new problems. The solution Hagen's unit developed combined flamethrowers with a new weapon just arriving in theater, white phosphorus shells from the Army's 4.2-inch chemical mortar. The mortars would fire white phosphorus into cave entrances, creating smoke that forced defenders deeper into the caves and marked positions for flamethrower operators. Hagen would then approach under covering fire and use his M2-2 to pump napalm into the cave entrance, creating sustained flames that consumed oxygen throughout the cave system. Finally, engineers would seal the entrance with demolitions. This three-phase tactic proved devastatingly effective at Peleliu. The white phosphorus smoke not only forced defenders away from cave entrances but also created respiratory distress that weakened their resistance. Hagen's sustained flame, made possible by the M22's doubled fuel capacity, created fires that burned for several minutes after the initial application, allowing oxygen depletion to kill defenders in galleries far beyond the flame's direct reach. The final demolition sealed the position, preventing defenders from reoccupying it even if some survived deep in the cave system. Over Peleliu's 73 days of combat, Flamethrower operators neutralized an estimated 300 cave positions, more than any previous Pacific battle. The weapons had evolved from specialized assault tools to essential components of cave warfare doctrine. But the casualty statistics remained sobering. 14 of 24 operators became casualties, a 58% loss rate that exceeded the division's overall casualty rate of 46%. The nature of cave warfare meant that even with improved tactics, flamethrower operators still had to expose themselves at close range to achieve weapon effectiveness. The psychological impact on operators intensified with the cave warfare at Peleliu. Unlike bunker assaults where defenders usually died quickly from flame or oxygen depletion, cave fighting sometimes produced situations where defenders survived deep in the complex but died slowly from burns or asphyxiation. Operators could hear screaming from deep inside caves, sounds that continued for minutes or even hours after the initial flame attack. Many operators reported nightmares and psychological trauma that persisted for decades after the war. Corporal Hagen, interviewed in 1986, reflected on his Peleliu experience with characteristic honesty. "We did what we had to do. Those caves couldn't be taken any other way. But what we did to the men inside them, that stays with you. I can still hear them sometimes late at night. You tell yourself it was war, that they would have done the same to us. That's all true. But it doesn't make the memories easier." By late 1944, the M2-2 flamethrower had become one of the Pacific War's most tactically significant weapons despite being one of its least numerous. Statistical analysis showed that in operations where flamethrowers were employed, overall casualties decreased by an average of 32% compared to similar operations without flame support. The weapons enabled Marine units to reduce fortified positions that conventional arms couldn't neutralize at acceptable cost. Japanese defensive doctrine continued evolving in response to American flamethrower tactics. Documents captured on Iwo Jima in February of 1945 revealed sophisticated anti-flame measures. General Tadamaki Kurabayashi, commanding the island's defense, had issued specific orders regarding flamethrower countertactics. Positions were to be constructed with multiple chambers and offset entrances to prevent flame penetration. Snipers were allocated additional ammunition specifically for targeting operators. Infantry units were instructed to attempt to rush flamethrower positions during the vulnerable refueling process. The February 1945 invasion of Iwo Jima saw the largest concentration of flamethrower operations in the Pacific War. The 3rd, 4th, and 5th Marine Divisions landed with 72 M2-2 flamethrowers distributed among assault battalions. The volcanic island's elaborate defensive system, featuring 11 miles of interconnected tunnels and 1,500 fortified positions, created conditions where flamethrowers became essential rather than optional. Corporal Herschel Woody Williams, serving with Company C, 21st Marines, conducted flamethrower operations at Iwo Jima that would earn him the Medal of Honor. Over 4 hours on February 23, 1945, Williams neutralized 7 Japanese pillboxes that had stopped his battalion's advance. His actions illustrated both the M22's capabilities and the extraordinary courage required to operate it effectively. Williams's assault began when his company encountered a complex of pillboxes near the Motoyama No. 2 airfield. Previous attempts to reduce the positions had failed with heavy casualties. Williams volunteered to attempt a flamethrower assault, advancing with 4 riflemen as his protection team. The approach required crossing 200 yards of exposed ground swept by machine gun fire from multiple positions. The first pillbox fell to a textbook assault. Williams's protection team suppressed the firing aperture while he advanced to 40 yards distance. His first flame burst struck the concrete structure, napalm flowing through the firing port and igniting everything inside. But as he traversed toward the second pillbox, both riflemen providing covering fire were hit by Japanese snipers positioned specifically to target flamethrower support teams. Williams found himself with just 2 protection team members remaining, facing 6 more pillboxes. The tactical doctrine called for withdrawing and requesting tank support. Williams instead continued the assault, using destroyed Japanese aircraft as cover for his approach. He neutralized the second and third pillboxes with sustained flame, expending most of his fuel supply. Rather than withdraw, he returned to Marine lines alone, obtained a refueled flamethrower, and resumed the assault. Over the next 3 hours, Williams made 4 trips to marine lines for refueling, each time returning alone to continue reducing Japanese positions. His protection team, reduced to 2 men, couldn't keep pace with his repeated assaults. By the time he had neutralized the 7th pillbox, Williams had been under continuous enemy fire for 4 hours, survived countless near misses, and demonstrated courage that impressed even hardened combat veterans. Williams's Medal of Honor citation noted that his actions enabled his battalion to advance 400 yards and reduce casualties by an estimated 200 Marines. More significantly, his one-man flamethrower assault became legendary among Iwo Jima veterans, demonstrating what a skilled operator with an M2-2 could accomplish when necessity demanded extraordinary action. Williams would survive the war and live until June of 2022, becoming the last surviving World War II Medal of Honor recipient. The Iwo Jima campaign consumed enormous quantities of flamethrower fuel. The 3 Marine divisions expended an estimated 70,000 gallons of napalm mixture over 36 days of combat, an average of nearly 2,000 gallons per day. This consumption rate created significant logistics challenges, as the fuel had to be mixed on-site from components shipped separately. Supply units established fuel mixing stations on the beach, operating continuously to keep pace with frontline consumption. The reliability of the M2-2 under Iwo Jima's harsh conditions exceeded expectations. The volcanic ash that clogged weapons and damaged equipment had minimal impact on flamethrowers, as the simple mechanical design had few moving parts to foul. Electrical ignition systems, the most vulnerable component, proved remarkably resilient. Of 72 flamethrowers committed to the battle, only 8 experienced mechanical failures, an 11% failure rate that compared favorably to more complex weapon systems. Japanese defenders at Iwo Jima employed every anti-flamethrower tactic developed during the war, with mixed results. Snipers targeting operators achieved some successes, killing 18 flamethrower men during the campaign. But the integration of flame operations with tank support meant that most operators approached targets under armored cover, making them difficult targets. The offset firing ports and multi-chamber bunker designs reduced flame penetration effectiveness but couldn't eliminate the threat entirely. One captured Japanese officer, Lieutenant Shigeru Yoshida, provided post-battle testimony about facing flamethrowers at Iwo Jima. The flame tanks were terrible, but the portable flamethrowers were worse in some ways. They could reach positions the tanks couldn't access. We knew to target the operators, but they advanced with tank protection or used terrain that made them difficult to engage. Once they reached effective range, there was nothing we could do. Our bunkers became ovens. The April through June 1945 Battle of Okinawa represented the final major employment of M2-2 flamethrowers in World War II. The 1st and 6th Marine Divisions, along with Army divisions that had adopted Marine flamethrower tactics, fielded over 100 M2-2 units during the 82-day campaign. Japanese defenders, the 32nd Army under Lieutenant General Mitsuru Ushijima, had constructed defensive positions incorporating every lesson learned from previous battles. The cave systems on Okinawa exceeded even Peleliu in complexity. Some cave complexes featured multiple levels connected by staircases carved into limestone, with chambers large enough to hold hundreds of defenders. The Japanese had positioned artillery pieces inside caves, firing through camouflaged apertures and then withdrawing into protected galleries. Neutralizing these positions required sustained flamethrower operations that pushed the M2-2 to its performance limits. Marine and Army flamethrower tactics at Okinawa reached their highest level of sophistication. Flame operations integrated with tank-mounted flamethrowers, providing both portable weapons for accessing difficult terrain and armored flame projectors for more exposed positions. Artillery fired white phosphorus to mark targets and create smoke cover. Engineers followed immediately behind flamethrower assaults with demolitions to permanently seal neutralized positions. This combined arms approach reduced operator casualties to their lowest rates of the war, approximately 35% across all divisions. The statistics from Okinawa told the M2-2's final combat story. Over 82 days, flamethrower operators neutralized an estimated 600 Japanese positions, consumed 90,000 gallons of napalm fuel, and suffered 112 casualties among the approximately 300 operators who saw combat. The weapons had proven indispensable for reducing fortified positions, but their terrible cost in blood remained a constant throughout the war. The planned invasion of Japan, Operation Downfall, prompted massive expansion of flamethrower production and training. The Chemical Warfare Service projected requirements for 5,000 M2-2 units to equip assault divisions for the November 1945 Kyushu landing. Training programs expanded to create a pipeline of 10,000 operators, recognizing that casualties would exhaust the initial operators within weeks of landing. The atomic bomb's use in August 1945 eliminated this requirement, leaving thousands of newly manufactured flamethrowers unused. The post-war fate of M2-2 operators varied widely, but common threads emerged in their experiences. Many struggled with what would later be recognized as post-traumatic stress disorder. The intimate nature of flamethrower combat, engaging enemies at close range and inflicting death by burning, created psychological burdens that many carried for life. Operator reunions, held annually beginning in 1947, provided venues where veterans could discuss experiences too terrible for civilian understanding. The last formal reunion of World War II flamethrower operators occurred in 2009 at Camp Pendleton, California, attended by just 14 surviving veterans. Their average age exceeded 85 years, and most had never spoken publicly about their service until late in life. One operator, speaking on condition of anonymity, provided a reflection that captured their collective experience. "We were boys who did a man's work with the devil's tool. The flamethrower saved American lives, that's undeniable. But what it cost us, what it cost the men we burned, that's something history books can't really measure." The M2-2 flamethrower served in Korea from 1950 to 53, where its effectiveness against Chinese bunker complexes mirrored its Pacific War success. By the Vietnam War, newer models had replaced the M2-2, though the basic design principles remained largely unchanged. The weapon's final combat use by American forces occurred in 1978, ending a service life that had begun 35 years earlier. Modern military forces have largely abandoned flamethrowers in favor of thermobaric weapons and precision munitions, but the M2-2's legacy persists in military doctrine addressing fortified position reduction. The Japanese perspective on facing M2 flamethrowers emerged slowly through post-war interviews and captured documents. Former Lieutenant Masao Hayashi, who survived the Iwo Jima battle, provided extensive testimony in 1952. The Americans had many terrible weapons, artillery, naval gunfire, aircraft, but the flamethrowers were uniquely horrifying. They turned our strongest positions into death traps. No amount of concrete or steel could protect against burning petroleum that flowed like water. We trained to fight courageously, to die honorably. The flamethrowers didn't allow for that. They killed indiscriminately, brutally. The technical achievement represented by the M2-2 merits recognition beyond its combat employment. The weapon incorporated innovative engineering across multiple disciplines, fluid dynamics for fuel projection, electrical systems for reliable ignition, materials science for lightweight pressure vessels, and chemical engineering for napalm development. The design balanced competing requirements for range, fuel capacity, weight, and reliability, achieving performance that exceeded all previous portable flamethrowers. Production statistics reveal American industrial capacity mobilized for war. The Chemical Warfare Service manufactured approximately 24,000 M2-2 units between March 1943 and August 1945, an average of 800 units per month sustained over 30 months. This production occurred simultaneously with hundreds of other weapons programs, illustrating the industrial depth that gave America decisive advantages in equipment quality and quantity. The human cost of the M2-2's success cannot be obscured by technical achievements or tactical victories. Approximately 1,400 American flamethrower operators died in combat during World War II, with another 2,200 wounded. The casualty rate among operators, roughly 60% across the entire war, exceeded rates for almost every other infantry specialization. These men, mostly volunteers aged 18 to 22, paid in blood for the tactical advantages their weapons provided. Japanese casualties from flamethrower attacks remain impossible to calculate precisely, but estimates based on position reductions and average defenders per position suggest between 15,000 and 20,000 Japanese soldiers died from flamethrower-inflicted burns, suffocation, or oxygen depletion. Many more were burned but survived long enough to be killed by other means or died later from burn injuries. The manner of death, incineration or asphyxiation in sealed bunkers, violated cultural expectations for honorable warrior death, creating psychological trauma among survivors that persisted for decades. The moral questions raised by flamethrower employment remain unresolved. The weapons inflicted terrible deaths, yet they also saved thousands of American lives by reducing fortified positions that conventional assault would have taken at catastrophic cost. The operators themselves were victims in a sense. Young men who volunteered for extraordinarily dangerous duty and often paid with their lives or psychological health. The Japanese defenders, fighting from fortified positions, had chosen defensive tactics that made flamethrowers the logical American response. Military ethicists have debated flamethrower morality since their introduction, with no consensus emerging. Some argue that any weapon reducing overall casualties is ethically justified regardless of the manner of death it inflicts. Others contend that weapons causing unnecessary suffering exceed moral boundaries even when tactically effective. The soldiers who employed and faced flamethrowers rarely engaged these philosophical debates, focused instead on survival and mission accomplishment. The M22's legacy extends beyond its direct combat employment to its influence on military doctrine. The weapon demonstrated that specialized tools, properly employed, could overcome defensive positions that conventional weapons couldn't reduce efficiently. This principle that tactical problems require purpose-designed solutions rather than simply more firepower became foundational to modern military thinking. The integration of flamethrowers with tanks, engineers, and infantry pioneered combined arms tactics that remain central to current doctrine. The technological evolution from the M2-2 to modern thermobaric weapons follows a direct lineage of development focused on defeating fortified positions through heat and overpressure. Current weapons employ different mechanisms, explosive dispersal of fuel-air mixtures rather than projected burning liquid, but serve the same tactical purpose the M2-2 fulfilled in the Pacific War. The principle that enclosed spaces can be neutralized through atmosphere manipulation rather than structural destruction traces directly to flamethrower employment lessons. The personal stories of M2-2 operators, both those who survived and those who died, deserve remembrance as more than statistics or tactical case studies. These were individuals who volunteered for exceptionally dangerous duty, trained extensively to employ a specialized weapon, and faced combat conditions that tested human endurance and courage to their limits. Many never spoke of their experiences, carrying psychological burdens in silence until death. Those who did share their stories late in life often expressed pride in their service mixed with horror at what they had witnessed and inflicted. Corporal Andrew Hogan, whose Bougainville assault opened this narrative, survived the war and lived until 1998. He rarely discussed his flamethrower service with family, speaking extensively about it only once, during a 1994 interview for a Marine Corps oral history project. His reflections capture the complex emotions common among operators. "I was 20 years old, scared every single day, but proud of what we accomplished. The flamethrower was a terrible weapon, but it worked. We saved Marine lives by taking those bunkers out. I wish there had been another way, but there wasn't. So we did what we had to do and we lived with it afterward. That's all you can do." The final assessment of the M2-2 flamethrower's role in the Pacific War must balance its tactical effectiveness against its human cost. The weapon enabled American forces to reduce Japanese fortified positions at acceptable casualties, shortening battles that might otherwise have lasted months and cost tens of thousands more lives. The operators who wielded these weapons displayed extraordinary courage, advancing into enemy fire while carrying conspicuous and vulnerable equipment. The Japanese defenders who faced flamethrowers suffered deaths that defied their cultural expectations for honorable combat. The M2-2 represented American industrial capacity, scientific innovation, and tactical adaptability, converging to create a weapon system that achieved its intended purpose. From its introduction at Bougainville in November 1943 through its final Pacific War employment at Okinawa in June 1945, the weapon evolved from an experimental tool to an essential component of assault operations. The 40-yard range that doubled the M1's capability proved exactly sufficient to allow operators to engage targets while surviving long enough to complete their missions. The legacy of the M2-2 lives on in the few surviving examples preserved in military museums, in the memories of the dwindling number of veterans who witnessed its employment, and in the tactical doctrines it influenced. The weapon itself is obsolete, replaced by more modern systems that achieve similar effects through different mechanisms. But the principles it embodied, specialized tools for specialized problems, integration of unique capabilities into combined arms operations, and the recognition that tactical innovation can overcome defensive advantages, remain relevant to contemporary military thinking. The men who operated M2-2 flamethrowers in the Pacific War deserve recognition not as warriors who gloried in their weapons' terrible effectiveness, but as soldiers who accepted extraordinarily dangerous duty because their service saved the lives of fellow Marines. They carried psychological burdens that many never fully resolved, haunted by memories of deaths they inflicted even while understanding those deaths were militarily necessary. Their sacrifice, both those who died in combat and those who survived with permanent psychological scars, contributed to Allied victory in a war that demanded such sacrifices. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.